Today we are mastering data privacy and factory functions with closures. In part 1 of this series, we learned that JavaScript functions carry a secret backpack, a closure that remembers the variables from where the function was born. That is a cool party trick, but why do we actually care? Well, what if I told you that this invisible backpack is the ultimate security system for your code? You see, out there in the global scope, it is the Wild West. Other developers, or even future you, can accidentally overwrite your variables, mess up your state, and crash your app. But today we are going to use closures to build an impenetrable vault around our data. By the end of this video, you'll be writing code like a senior engineer. Let's get into it. Let's imagine you're building a banking app. You have a variable called balance. If you leave balance out in the open global scope, anyone can touch it. Some random piece of code could just say balance equals potato, and suddenly your entire app breaks. We want to protect that balance. We want to make it so the only way to interact with the money is through strict rules that we define, like a deposit or withdrawal function. This concept is called data privacy or encapsulation. And in JavaScript, closures are the perfect tool for the job. Let's write a function that creates a secure bank account. So I write a function create bank account, which takes a parameter initial balance, and then I declare a variable balance, which will be initially set, and this is our hidden treasure, which we should protect. Then, instead of returning a single function, this time we need to return an object which contains two functions, because we have to consider both deposit and withdrawal. So for deposit, we need to take the amount, and let me just copy and paste it. For withdraw, same story, but for deposits, we need to increase the balance using plus equals assignment operator. We add the specified amount to the balance, and let's print a message to the console. Deposited amount. Here I use template literals, and new balance is balance. And let me again copy and paste this to save some time. For withdrawal, instead of increasing, we need to deduct from the balance, and also the message should be adjusted. We drew the amount, and then we also print the new balance. Of course, we need to check something here. If the amount is greater than balance, then apparently this is not possible, so we would have negative balance, which is not desirable. Let's log declined. You are broke, and finally we just return. Perfect, I save it. Look closely at balance. It is a local variable inside create bank account. Once this function finishes running, balance is gone from the outside world. You cannot access it directly. But we aren't returning a single function this time. We are returning an object full of functions. And because of closures, every single function inside this object gets access to the same invisible backpack containing balance. Cool, now let's use this function. So I declare a constant, assign function, create bank account to it, initial amount or initial balance is 100, and then let's also call deposit and withdraw functions here. For example, I deposit $50 or euros, and then let's withdraw, for example, $20. I save this, and now let's check whether it's working. I go to the console tab, and yeah, you see, deposited 50, new balance is 150, then withdrew 20, new balance is 130. So this balance variable is remembered. It works. The closure remembers the balance. Now watch what happens if some nosy hacker tries to mess with my money directly. Okay, so here let's set the balance to 1 million and then log my account.balance. What is the output? I save this and let's go back to the console tab. Wow, 1 million. Did they just become a millionaire? Let's check by doing a legitimate withdrawal. Okay, here, let me scroll down a bit. This time, let's withdraw, for example, $10 and save that. Great. Nice try, hacker. My account.balance equals 1 million just added a completely useless public property to the object. It did not touch our secure private balance variable safely tucked away inside the closure backpack. The real balance went from 130 to 120. Data privacy achieved. What we just built is actually called a factory function. It's a function whose sole purpose is to manufacture and pump out new objects or functions. Factory functions combined with closures let you stamp out multiple independent instances of something, each with its own private state. Let's look at one more quick example, a video game character generator. Okay, cool. So I'll comment out all of these lines. Let's write a function. Function create player. We need to take player's name. And here I declare a variable xp, which is initially 0. This is our private variable, and then this time we return a function. We increase xp and finally print a message to the console name, which represents player's name, leveled up, and then total xp is xp. Okay, I save this and then let's declare two constants, level up Mario, then we assign create player to that, Mario, and let me copy and paste it. This time level up Luigi, which is another player, and then I pass Luigi as the argument to this function. Cool. I save it. We just used our factory function to create two distinct players. Even though they came from the exact same create player function, they each get their own independent closure backpack. So now I call level up Mario twice and level up Luigi once. Cool. I save this and let's go to the console tab. Here you see, first we get Mario leveled up, total XP 100. Then when we call the function for the second time, we get Mario leveled up, total XP 200. And finally, when we call level up Luigi, this message is printed in the console. Luigi leveled up, total XP 100. Amazing. Mario leveling up has zero impact on Luigi's XP. They are completely separate. Factory functions allow you to write reusable, modular code without worrying about variables bleeding into each other. And there you have it. Closures aren't just some weird JavaScript quirk designed to torture you in job interviews. They are incredibly powerful tools. They give us the invisible backpack we need to create private variables, build secure objects, and design beautiful factory functions. If you finally understand closures and feel ready to conquer your next project, hit that like button to let me know. Make sure you subscribe and let me know in the comments what topic you'd like me to cover next. Until next time, keep coding, keep learning, and as always, stay awesome.